Here we have a logarithm problem in IIT JEE Main Mathematics. Okay, let's go to the question. The sum of the roots of the equation x positive 1 negative 2 times log base 2 of 3 positive 2 to the x bar positive 2 times log base 4 of 10 negative 2 to the negative x bar equals to 0 is. Okay, for this equation, what we have to do is we have to find the sum of the roots. That is, the roots means the values of x we have in this equation. So first we have to get the values of this values of x in this equation, and then we have to add the values of x. That gives us sum of the roots of this equation. Okay, in my first step, what I'm going to do is in this equation, I'm going to write this x positive 1 as a product of x positive 1 times 1. Let me write over here. That is, I'm writing this x positive 1 as x positive 1 times 1. So even when I multiply this x positive 1 by 1, still I'm getting the same stuff. Then we get negative 2 times a log base 2 of 3 positive 2 to the x power positive 2 times a log. So here the base is 4. Actually, it's a power of 2. Since the 4 is a power of 2, this 4 can be written as a 2 square of 10 negative 2 to the negative x power equals to 0. Okay, here let me write x positive 1. Now I'm going to write this 1 in terms of logarithm. So that is a log base 2 of 2. In any logarithm, if the argument and the base are equal, then the value of such logarithm is 1. So the logarithm I have written over here is equal to 1, because in this logarithm the argument and base are equal, negative. And now we can move this 2 as the exponent of this argument over here using the power rule of logarithm. So then whenever there is a number multiplied in front of logarithm, it can be taken as the exponent of the argument. So we can do this using the power rule of logarithm. Then I'm getting log base 2 of 3 positive 2 to the x power the whole square. That is, this 2 is taken as exponent for this argument. Here the base of this logarithm is a power, that is 2 square. So whenever the base of a logarithm is a power, the exponent we have over here at the base can be moved in front of the logarithm. When I move this exponent 2 in front of logarithm, it will become its reciprocal. Already we have 2 over here. Now when I move this exponent 2 at the base in front of the logarithm over here, so we have to consider the reciprocal of this 2. Then I'm getting 2 times 1 over 2 times log. Now we have just base 2, because this exponent is moved in front of the logarithm of 10 negative 2 to the negative x power equals to 0. And here this 2 will cancel out. Then I'm getting, and also here I can use the power rule of logarithm. That is, the stuff we have multiplied in front of the logarithm can be taken as exponent of the argument of the logarithm. Then I'm getting log base 2 to the power of x positive 1. So this is taken as exponent of the argument over here. Then we get negative log base 2 3 positive 2 to the x power the whole square positive. So here we have just 1. When I multiply this logarithm by 1, I'm getting the same stuff. That is log base 2 of 10 negative 2 to the negative x power equals to 0. Okay, now here we have 3 logarithms with the same base 2. Whenever 2 logarithms are in subtraction with the same base, what we can do is we can write the logarithm once with the base of what we have for the 2 logarithms, and we have to divide the arguments. So we do this using the coefficient rule of logarithm. Okay, now for these 2 logarithms, I have taken a logarithm with whatever base I have for these 2 logarithms. Now what I have to do is I have to divide the arguments, because the 2 logarithms are in subtraction. So this is said by the coefficient rule of logarithm. Then I'm getting 2 to the power of x positive 1 divided by 3 positive 2 to the x power the whole square positive log base 2 of 10 negative 2 to the power of negative x equals to 0. Okay, here we have addition of 2 logarithms with the same base. Whenever we have addition of 2 logarithms with the same base, what we can do is we can write logarithm once with whatever base we have for the 2 logarithms, and we have to multiply the arguments. When 2 logarithms are in subtraction, we divide the arguments using the coefficient rule. When we add 2 logarithms with the same base, what we have to do is we have to multiply the arguments. So we do this using the product rule of logarithms. Okay, now let me continue that on the next page. Okay, let me write the logarithm with the base of what we have, that is 2. And now what I have to do is I have to multiply these 2 arguments. When I multiply these 2 arguments, I can multiply the numerator over here by this stuff, that is 10 negative 2 to the power of negative x. And we can take this one as a denominator. Okay, let me do it. So then I'm getting 2 to the power of x positive 1 times 10 negative 2 to the power of negative x, all divided by 3 positive 2 to the power of x, then whole square equals to 0. Okay, here it's a logarithmic equation. Now I'm going to convert this equation to exponential form. So whenever I want to convert the logarithmic equation to exponential form, I have to consider the part which contains logarithm. Here the stuff on the left side contains logarithm. Now what I have to do is I have to move this logarithm with base 2 to the right side of the equation. When I move this log base 2 to the right side of this equation, I have to ignore this logarithm and I have to consider only the base 2 on the right side of the equation. The value which already exists on the right side will become the exponent of this base. Already we have 0 on the right side. This 0 will become the exponent of this base 2. Now we have this stuff on the left side, that is 2 to the power of x positive 1 times 10 negative 2 to the power of negative x all divided by 3 positive 2 to the power of x the whole square. Okay, now I can distribute this 2 to the power of x positive 1 to this 10 and this 2 to the power of negative x. Then I'm getting 2 to the power of x positive 1 times 10 negative 2 to the power of x positive 1 times 2 to the power of negative x all divided by, let me write it, all divided by 3 positive 2 to the power of x the whole square, and anything raised to the power 0 is just 1. Now we can write this 2 to the power of x positive 1 as 2 to the power of x times 2 to the first power, because when I multiply them, so here I multiply two terms with the same base, so we can take the base 2 once and we have to add the exponents. So the product of this 2 to the x power and 2 to the first power equals to 2 to the power of x positive 1. So the stuff what I have written over here is equal to 2 to the power of x positive 1, and whenever there is an exponent 1, we don't have to mention, simply we can write as 2 times, we can write this number 10. And here we multiply two terms with the same base 2. So what we can do is we can take the base once and we can add the exponents. Then I'm getting x positive 1 negative x over 3 positive 2 to the power of x the whole square equals to 1. Okay, now let me continue over here. Now we can multiply this 2 and 10. Then I'm getting 2 to the power of x times 20, or it can also be written as 10 times 2 to the power of x. And here this positive x negative x will cancel out. I am getting just 2 to the first power, that is just 2 divided by 3 positive 2 to the power of x the whole square equals to 1. Okay, now to get rid of this denominator, I multiply both sides by this stuff. Otherwise, we can move this stuff, we can move this denominator to the right side. It will be multiplied by this one. That is 1 times this stuff is the same. So then the resulting equation is 10 times 2 to the x power negative 2 equals to 1 times this denominator is 3 positive 2 to the x power the whole square. Okay, now we have 10 times 2 to the x power negative 2. Now we can expand the square of the binomial using the a positive b the whole square equals to, that is a square positive 2ab positive b square. So already we are familiar with this, the expansion of the square of the binomial over here. At the place of a we have 3, at the place of b we have 2 to the x power. In this expansion we can replace a by 3 and b by 2 to the x power. Okay, let me do it. Then we get 3 square positive 2 times 3 times 2 to the x power positive 2 to the x power the whole square. This a square positive 2ab positive b square. Okay, now what we can do is we can write the stuff on the left side as it is 10 times 2 to the x power negative 2, and the value of this 3 square is 9. Positive 2 times 3 is 6 times 2 to the x power positive 2 to the x power the whole square. Okay, now to make the solving process a little easier, what I'm going to do is, so I'm going to assign a new variable y for this 2 to the x power, because I find 2 to the x power over here, here and here. So let me assign the new variable y for this 2 to the x power. Then this equation will become, so 10 times for this 2 to the x power we can plug in y, then we get 10y negative 2. On the right side we get 9 positive 6y, because 6 times y positive. Here this 2 to the x power is a square, then we get a y square. So now what we can do is I can subtract 10y from both sides, and also let me add 2 to both sides. So to get a quadratic equation standard form, actually we have a quadratic equation in y. So to get the quadratic equation in standard form, we have to get all the terms on one side of the equation, on the other side we must have 0. So now I'm trying to make the right side 0. For that I have to get rid of this 10y and negative 2. To get rid of this 10y, I just subtract 10y from both sides, and to get rid of this negative 2, add 2 to both sides. So here positive 10y, negative 10y will cancel, negative 2 positive will cancel, we get 0 on the left side. And when I combine this 9 and 2, I'm getting 11. And when I combine this positive 6y and negative 2y, I'm getting negative 4y positive y square. Okay, now let me continue on the next page. So we have 0 equals to 11 negative 4y positive y square, 4y positive y square. or the same equation can be, I mean, we can rearrange the terms over here. First, we can write the square term y square negative 4y positive 11, or the same equation can be written as y square negative 4y positive 11 equals to 0. Actually, this y is a variable taken by us. Now it has to be replaced by the original stuff, that is 2 to the x power. So when I replace this y by 2 to the x power, then I'm getting 2 to the x power the whole square negative 4 times 2 to the x power positive 11 equals to 0. Okay, again, we have a quadratic equation in terms of the variable 2 to the x power. Okay, solving this quadratic equation will give two values for this 2 to the x power. Now, let me assume the first value for this 2 to the x power as 2 to the power of x1, and the second value of this 2 to the x power is 2 to the power of x2. So, these are the two roots of this quadratic equation. And also, when I consider this stuff, we have x at the exponent. Actually, this x is the original variable we have in the given equation, and the values of x give the roots of this equation. Okay, since the x represents the roots of the given equation, so this x1 and x2 are the two roots of the given equation. According to the question, we have to find the value of x1 positive x2, that is the sum of the two roots of the given equation. Okay, now it's very clear. For the given equation, we have two roots. I mean, we have two values for x. One is x1, another one is x2. Okay, and already we know that these two are the roots of this quadratic equation. When we have a quadratic equation in standard form, that is ax square positive bx positive c equals to 0, there is a formula to get product of the two roots. Let me write the stuff over here. Product of the two roots equals to, we have to divide the constant term c by the coefficient of the squared term, that is a. Okay, here in our quadratic equation, the two roots are 2 to the power of x1, 2 to the power of x2. So to get product of the roots means we have to multiply these two roots, that is 2 to the power of x1 times 2 to the power of x2, which is equal to, so we have to divide the constant term by the coefficient of the square term. So here the constant term is 11 and the coefficient of the square term is just 1, 11 over 1. Okay, here we multiply two terms with the same base 2. So now what we can do is we can take the base ones and we have to add the exponents. So there is x1 positive x2, which is equal to 11 to the 11 over 1 is just 11 on the right side. Okay, now my aim is to find the value of this x1 positive x2. Actually, this is an exponential equation. Now I have to convert this one to logarithmic equation so that I'll be able to get the value of this x1 positive x2. For that, what I have to do is I have to move this base 2 to the right side of the equation. When I move this base 2 to the right side of the equation, it will become log base 2, and the value which already exists on the right side will become the argument of this logarithm. The exponent on the left side will become the base, that is x1 positive x2. So already we have concluded that x1 and x2 are the two roots of the given equation, and now I got the sum of the roots of the given equation, that is equal to log base 2 of 11. Now let me go to the original question. So here we find the log base 2 of 11 in answer choice B. So therefore, the sum of the roots of the given equation is log base 2 of 11. That is answer choice B is correct.